What's going on, everyone? In today's video, we're going to be going over angles of elevation and depression, as well as a couple of example problems to help you know the difference between the two. And if you follow these steps, I promise that you're going to find these problems to be a whole lot easier. Let's go ahead and jump right in. One thing that's important to remember is that when you're considering what your angle of elevation or depression is, or would be, depending on if you're given it or if you need to solve for it, is that it's going to take into consideration a horizontal line, also using your line of sight. So if my line of sight is right there, it means that I am looking directly straight. Okay, so it's parallel with the ground. And if we look up, if we elevate our head, we are going to have an angle of elevation. So if we're looking at an object up here, maybe it's an airplane, top of a building, or a tree, something that's taller than us, we are looking, when we look straight and then we look up, that we're elevating our line of sight. Therefore, we are going to be having an angle of elevation. Now, if we're looking down towards the ground, maybe we're at the top of a cliff and we want to look at something on the bottom, or if we want to see like a squirrel or something that's on the ground, we are going to be looking straight and then we're going down. So remember, if you like depress anything, it's to put it down. Okay, so that's kind of some easy ways and semantics to remember what you're taking into consideration. So what does that actually look like in a word problem? Let's take a look. Okay, so let's say we have a ramp and we're going to be, this needs to be constructed to give wheelchair access to a door of a house that is 1.35 meters above the ground. However, safety regulations require that the angle of the ramp is less than 8, so that way it's a little bit easier to get up, and that way if you're going down, you're not just rolling out of control. So let's go ahead and draw a diagram and label the vertices and the sides. Now, even if this wasn't given to us as an instruction or as part of like a sub-problem, we should definitely be drawing diagrams. It's always helpful to draw and give a nice visual representation of what we're doing. So let's go ahead and let's draw this out. So we would have a starting point here. We're going to have a ramp that is going to go up to the start of a house. Wow. There we go. Front door. All right. Now remember, we also need our line of sight, or our line that either runs parallel with the ground or in this case is the ground. So we're going to be having a line that's going to go over here. And that is going to be a nice 90-degree triangle. Now we need to label the sides appropriately. So we're given that BC is the ramp. So I know that BC has to be the ramp. And so I'll go ahead and call this corner down here A. So now I have A, B, and C. Okay, I have a height of 1.35. So now I can go ahead and do part B. Find the length of the ramp where ABC is equal to 8. So if you remember what we were talking about with SOHCAHTOA, always a good idea to write that down as a nice, easy reference. So again, what we want to find is this length right here, BC. What we have is an angle. We have the opposite side, and then we have the hypotenuse. So which trigonometric ratio is going to take into account the opposite side and the hypotenuse? That's going to be sine. So I'm going to have the sine, and let me do one problem. The sine of 8 degrees is going to be equal to opposite 1.35 all over the hypotenuse, which is BC. Now rearranging, I'm just going to have BC is equal to 1.35 all over the sine of 8 degrees. And if you put that into your handy dandy calculator, you're going to get a value of 9.70. And you can see that I already did that here. I have 9.70015, but again, in our course, we take into account 3 significant figures. So 9.70 is going to be our answer. So for part C, we want to find the distance AB, and let's give our answer to 1 decimal place. So what we want to know is what this distance AB is. So there's different ways that we can do this with different trigonometric functions. But if I have 8 degrees here, again, I'm just going to keep relying on this right here because I know it's an exact answer. So I know that my height AC is 1.35, and I want to know what my adjacent side is to the angle. So what takes into account the opposite and the adjacent? That is going to be tangent. So the tangent of 8 degrees is going to be equal to 1.35 all over AB. So AB would therefore equal 1.35 all over the tangent of 8 degrees. And we will find that AB is going to have a distance of 9.61. Okay, we want this to 1 decimal place, so AB would be equal to 9.6. So 9.61 is what the answer would be to 3 significant figures, but our answer stipulates that we need to give it to 1 decimal place, so we'll round it to 9.6. All right, and there we have it. So that is how we can use the angle of elevation as well as the trig ratios we covered in the previous video to help solve a word problem and break it down with a nice little diagram. So let's take a look at a different problem. So now in this problem, we're given that someone is at point A, which is 6.5 meters above the ground, which is why 6.5 meters is right here. Okay, so Tom Chick is going to view the top and the base of the building on the opposite side of the street. So now we're given that the angles of elevation depression of the top and the base of the building are 55 degrees and 18 degrees respectively. And remember that respectively always just means kind of in order, meaning that 55 corresponds to the first one mentioned, which is angles of elevation, 55. And then since 18 is second, that's the angle of depression. So we want to find the height of the building that he is viewing corrected 2 decimal places. So we want to find out the height of the building, kind of C to D here. Now, we know that the angle of elevation is 55 degrees. So what does that mean? So remember that this person is at point A, 6.5 meters above the ground. So if they're looking straight and then up to the top of the building, that's our angle of elevation, which in this case is 55 degrees. And then the angle of depression, meaning when he's looking straight and then going down to the corner of the building right there, is going to be 18 degrees. 18 degrees right there. So we know that he's viewing these buildings from a height of 6.5. And that 6.5 is also going to be represented over here. That's one of the advantages of drawing a diagram, is that you can clearly see these shapes and relationships. So we'll have 6.50 meters over here. Now, what we want to do is find the height from D all the way up to C. So what we're missing is B to C, because we know that this is 6.5. We got to figure out what this second length is in order to find the total height. The problem here is that we don't know what this is. We don't know what this is. We don't know what that is, meaning that we need to do something involving 2 knowns, in this case 18 degrees and 6.5, in order to give us something in that top triangle, so that way we then have an angle and a side and we can use a trig ratio. So if we look at 18 degrees, and we see that the shared side that these 2 triangles have is right here, AB. So if I want to find out what AB is, I can clearly see that this right here is going to be the opposite. And then I can clearly see from here that this is the adjacent, because this right here would form a 90-degree angle. So this would be the hypotenuse, and we're not considering that. So we want to know the opposite in order to figure out the adjacent. So which one takes into account opposite and adjacent? That's tangent. So the tangent of 18 degrees is going to be equal to opposite 6.5 all over AB, meaning that AB is going to be equal to 6.5 all over the tangent of 18. Now, what does that equal? Well, you can put that in your calculator, and you'll find that you'll get 20.00. Now, this is 2 decimal places because that is what the problem is asking for, so I'm going to leave it like that. So I'll go ahead and add this into the diagram, that this right here is 20.00. Now, I know that I have 20.00 right here. So now I can figure out what CB is, because right here I have 55 degrees. So if I have 55 degrees, I want to know what CB is, the opposite side, and I know what my adjacent side is. So I'm going to go ahead and use the tangent again. So the tangent of 55 degrees is going to be equal to CB all over 20.00, meaning that 20.00 times the tangent of 55 degrees is equal to this height. So CB is going to be equal to 28.56 to 2 decimal places. So how do we find the total height of the building? Well, we know that CB and then BD are going to give us the total height. So if I have 28.56 as my CB, and then I'm going to have 6.50 as my BD, that sum is going to give me the total height, which is going to be 35.06 meters as the total height. All right. So I hope that explanation helped as to what the angle of elevation and depressions are. And remember, horizontal line, if you look up, it's elevation. If you look down, it's depression. And then all you have to do is use those with some of the trig functions that we have gone over in previous videos to solve for these types of word problems. I hope that shed a little bit of light into how to solve these and provided a little bit of clarity, and I'll see you all in the next video.